Alrighty, 13.4. Before we get into it, let's do a little review. Evaluating functions without using a calculator. Anytime you're doing this, the first thing you need to do is sketch the angle that is given. Sometimes it's given in degrees, sometimes it's given in radians. This time it is degrees. Okay, so 135, we need to sketch that angle. We got our initial side, 135 to 90. And then we got to go another 45, which leaves us 45 more degrees to get to the x-axis, which is our reference angle. Okay, and that's also going to be part of the right triangle that we create. And remember, whenever we create these triangles, we are always going to the x-axis. And if we create a 45, 45, 90, we know the sides to that special right triangle, or we should. And then the other thing, let's check our signs. We went left, so that's going to be negative, and we went up, which will be positive. And then we're going to evaluate the trig function sine from that angle of 45 there, meaning opposite over hypotenuse, which will give us 1 over square root of 2. Opposite side, hypotenuse, and then simplifying that, multiplying both top and bottom by the square root of 2, we get square root of 2 over 2. Double checking your sign. We know all students take calculus as our acronym. Sine and cosecant should be positive in the second quadrant, so our sign is good, and we have our answer of square root of 2 over 2. Okay, cosecant of 315 then. Again, positive angle, 9, 180, 270. We got to go another 45 degrees for our angle. Okay, which also leaves us another 45 degrees to get to the x-axis. So there's our reference angle, and we again have created 45, 45, 90, 1, 1, square root of 2. Now we went right, so that's positive, but we went down, so that side length is negative, and we're evaluating cosecant from this 45 here. Again, it's always the angle near the origin that you're evaluating from. So cosecant, which is the reciprocal of sine, so instead of opposite over hypotenuse, hypotenuse over opposite, which will be square root of 2 over negative 1, or just negative square root of 2. All students take calculus again, checking. Cosine and secant should be positive in the fourth quadrant. Cosecant is not cosine or secant, so it should be negative. Okay, just a little review, evaluating functions of any angle. So today on this video 13.4, we're going to talk about inverse trig functions. Inverse trig functions are going to help us find missing angles. We've used trig functions up to this point to help us find missing side lengths. So inverse trig, we're going to find the missing angles. Now, for the ones we're going to do without a calculator, again, you're going to need to know your special right triangles, okay? Just a quick definition, though. Inverse trig functions, finding the angles that correspond to a given value of a trigonometric function, okay? So when we look at inverse sine a square root of 2 over 2, okay, we're thinking, okay, from what angle did we evaluate sine to get square root of 2 over 2? Now, the only one you look at of your special right triangles and you have square root of 2 in is the 45, 45, 90. Okay, so and then you think, okay, we're going to go to each angle. Okay, let's go to and in this case, it does not matter which one you go to, but which one are you going to get opposite over hypotenuse to get square root of 2 over 2? So, going from, we'll just say that top one, opposite over hypotenuse, 1 over square root of 2, which simplifies to square root of 2 over 2. So let's just say, so sine of 45 is equal to 1 over square root of 2, or square root of 2 over 2. Those match up here. So the angle that we came from to get that was 45. So inverse sine of square root of 2 over 2 is 45 degrees. And again, it is an angle measure, so you need to make sure you have that degree symbol as well. Moving on to B there, cosine Inverse cosine of 3. Now, thinking about all the ratios that we can get, is there any possibility of getting 3 over 1? You know, only place I see a 3 is in 30, 60, 90 over here, triangle, and it's square root of 3. The only way, well, I shouldn't say that. There's no way of figuring out a ratio to get just 3. So let's just say we went from, let's go from 60, and we're thinking cosine, so adjacent over hypotenuse. So adjacent over hypotenuse, 1/2. Nope, we're looking to get 3. So let's go from 30 degrees, adjacent over hypotenuse. We get square root of 3 over 2. Okay, and then from there, there's no other options after that. So there was no possible way of getting 3. So in this case, there is no solution. Okay, finally the last one, inverse tangent of 1. So, you know, thinking about a ratio, you got to get 1 over 1. You go to the 30, 60, 90, there's no way of getting 1 over 1. It's going to be 1 over square root of 3, 1 over 2, something in that case. Okay, no way of getting 1 over 1. So I'm thinking, let's go from 45, and we're thinking tangent now. Tangent, TOA, opposite over adjacent, opposite over adjacent. I get that 1 over 1. So inverse tangent, well, let's just say tangent of 45 is 1 over 1, which is 1. And that is exactly what we were looking to get. So the angle that we went from was 45. So inverse tangent of 1 is 45 degrees. Okay. So when you're doing this and you don't have a calculator, have your triangles ready, okay? And then whatever the trig function is, okay, like that tangent, we're doing opposite over adjacent. Just go to each angle, do opposite over adjacent until you get that actual value from the ratio that you get when you do tangent from each angle. Okay. All right. So, a couple more practice. Inverse cosine of 2. You know, only way we're going to get inverse cosine of 2 is 2 over 1. So I got to go to that 30, 60, 90. Cosine, adjacent over hypotenuse. Okay. So adjacent over hypotenuse, okay, 1/2, nope, that doesn't work. So if I go from 30, adjacent over hypotenuse, still don't get it. Okay, it would have to be hypotenuse over adjacent. So there's no way of getting 2 when you evaluate cosine. So in this case, there is no solution. Whenever we're doing these, it has to be less than 1. Okay, so anytime you see inverse cosine, inverse sine, inverse tangent of 2 or 3 or 4, those are not going to be possible. So, just a little hint there. All right, let's go to inverse sine of 1/2. Okay, 1/2. Okay, I'm looking at my 30, 60, 90. There's a possible way of getting 1 over 2 there. Okay, so let's evaluate. Let's try from 60. So sine of 60 is going to give me opposite over hypotenuse, so square root of 3 over 2. Okay, that's not what I'm looking for. So, but inverse sine of 30, opposite over hypotenuse, so we get 1/2. That is what I'm looking to get, is the 1/2. And what angle did we go from? We went from 30 degrees. So the inverse sine of 1/2 is 30 degrees. We're finding that missing angle. All right. So tangent of square root of 3 over 3. I see square root of 3, so I'm instantly thinking 30, 60, 90. And let's just go start with one of the angles. Let's start with 60. So let's say sine of 60, and we're talking, oh, we're not doing sine, we're doing tangent. Tangent of 60, so opposite over adjacent. That's going to be square root of 3 over 1. Okay, we're close. We got that square root of 3, but we need the square root of 3 over 3. So let's go to 30 degrees. Tangent of 30. Opposite over adjacent is going to give us 1 over square root of 3, which we need to simplify to get square root of 3 over 3, which is exactly what we're looking for. Okay, you see square root of 3 over 3. Square root of 3 over 3. And the angle we went from to get that was that 30 degrees. So inverse tangent of square root of 3 over 3 is 30 degrees. Oop. Come on. All right, so now given a triangle and we have two sides, find that missing angle. What we need to do is you can pick any type of, let's see. So what I'm thinking here, we're trying to find theta, which is our angle, and I have the opposite and the hypotenuse. So the trig function that we're going to use for that is sine. So I'm thinking sine of theta, we don't know what theta is equal to 7 over 12. So now the question is, how am I going to figure out theta? Okay, just like when we say x plus 3 equals 7, you know, we have to subtract 3 from both sides, because subtracting is the inverse operation of adding. So the same idea here. We need to use the inverse operation of sine, which is inverse sine. So we're going to take the inverse sine of both sides, and that's going to take care of that, and it's just going to leave us with theta is equal to inverse sine of 7/12. Now in these cases, you will have a calculator. So I'll show you how to do that real quick. Looking at it, it's just going to be second and then your sine. Okay, that's your inverse, and it was inverse sine of 7/12. So 7 divided by 12. Hit enter, and we get 0.6. Now again, we should be getting an angle in terms of degrees. So the other thing we need to make sure is we are in terms of degrees. Okay. So then going back and then doing the 7 divided by 12. 35.7 if we go to the hundreds. Okay, so our theta is 35.7 degrees. Okay, that other one was in terms of radians. If we're finding an angle for a triangle, do it in terms of degrees. Okay. So you should get something between probably 0 and 90 in most cases. Well, in a right triangle, you will, because you have your 90-degree angle, meaning these two have to add up to be 90. So it will be somewhere between 0 and 90. All right, next one. If we look at it, we have opposite and we have adjacent. So I'm thinking tangent. Tangent of theta is equal to 18 over 13. And again, to undo the tangent of theta, to get just theta, we're going to take the inverse tangent. So we got theta is equal to inverse tangent of 18 over 13, which I won't show you how to do again. Make sure your calculator is in terms of degrees. Type it in, second tangent, 18 divided by 13. You're going to get theta is equal to 54.2 degrees. Now keep in mind what I tell you to round to. That's the place why you should round to. And then again, it's a degree measure, so make sure you have your degree symbol. So now same thing here, solve the equation. That's exactly, we came up with the equation given the triangles up here. So to solve for this equation, find theta, you're just going to take the inverse cosine of both sides. So theta is equal to inverse cosine of 2/3, which type that into your calculator, you get 48.2 degrees. Okay, same thing here. Take the inverse tangent of both sides. You get theta is equal to inverse tangent of 2.7, which is going to give us 69.7 degrees. So anytime you're doing inverse trig functions, you are finding a degree measure for an angle. Don't worry about all these exit slips. I'm not sure if that's exactly, I don't believe that's your homework assignment. I believe it's a worksheet. Other than that, if you have questions, make sure you're coming in during office hours, and have a good week.